Today, I want to tell you about a very old experiment. A scientist saw a strange light inside a glass tube. The light moved long and narrow in the darkness. Have you ever thought about why such a light appeared?
I don't know. Isn't it just light, like a lamp?
Many people thought so too. But this light was different from a lamp. The inside of the glass tube was almost a vacuum with hardly anything in it. Yet, the light moved from one side to the other. So the scientists were curious about what this light was.
Isn't there nothing in a vacuum? Then how can light exist?
That's exactly what was fascinating. So the scientists called this light cathode rays. But no one really knew what cathode rays were. Some people said it was light, while others said it was something very small moving.
If it's something small, is it like dust?
It could be much smaller than dust. But at that time, people didn't think there was anything smaller than an atom. So the idea that something small could move was hard to accept.
So the scientists had different ideas?
That's right. Some scientists said that cathode rays are light that moves like waves. Another scientist claimed that cathode rays are very small particles. The debate continued because they had differing opinions.
Why was it such an important issue?
It's because once you understand what cathode rays are, it can completely change the way you see the world. If cathode rays are particles, it meant that there were things smaller than atoms. That was a complete shift in the beliefs of people at the time.
So how did that light look?
A greenish line appeared on the inner wall of the glass tube. The line stretched straight from one side to the other. It looked like something invisible was quickly passing by and hitting the wall.
That must have been fascinating. I wonder what the scientists thought when they saw that.
Some people thought this light was related to electricity. Others thought this light was a new kind of energy. But no one could say for sure. So more experiments were needed.
Then who tried to solve this riddle?
Several scientists took on the challenge. But one person, in particular, showed a deep interest in this problem. He really wanted to know what this light was. So he began to prepare a very careful and elaborate experiment.
Why did that person work so hard?
He didn't just want to see the light. He wanted to know the secrets of nature. And he thought this light was hiding a very important secret of nature.
So this light wasn't just a pretty light?
That's right. This light was the key that opened the great door of science. But at that time, no one knew that fact. Everyone just thought it was a strange light.
So you didn't know why the light was moving?
That's right. So the scientists changed the shape of the glass tube and also the metal they put inside. But the light always moved in the same direction. It looked as if some force was pushing that light.
What could that force be?
That very question was the start of the next experiment. I thought that if we could find out what force this light responds to, we would also be able to identify the nature of the light.
Xiongqiu, a bigger experiment has begun?
That's right. And that experiment will change the course of scientific history. I'll continue that story in the next chapter. In the last story, we talked about a strange light called cathode rays. Now I want to introduce one person who tried to find out what that light really was. He was a very quiet scientist, but he had a very strong will. He was the kind of person who kept digging into a problem until the very end.
Why was he interested in that light?
Unlike other people, he thought cathode rays might not be simple light. He was someone who questioned everything. So he wanted to design his own experiments and check things for himself.
Where did he work?
He worked at the Cavendish Laboratory in England. It was a very famous laboratory. Many scientists made important discoveries there. He was the director of that laboratory, so he was free to do many experiments.
What kind of person was he?
He was very good at mathematics, and he did his experiments very carefully. He never ignored even small mistakes. When he saw a problem, he tried to solve it until the very end. That is why people respected him.
So he wanted to know what cathode rays really were?
That is right. He wanted to know, were cathode rays light, or were they tiny particles? He believed that solving this problem would move science one step forward.
How did he start his experiments?
First, he looked carefully at all the experiments that already existed. He checked what other scientists had done and what results they got, one by one. And then he found the weak points in those experiments. He thought more accurate experiments were needed.
So he created new experiments?
Yes. He built a device that could observe the cathode rays coming out of a glass tube more clearly. He used electric fields and magnetic fields to see how the cathode rays moved. He wanted to know how cathode rays responded to different forces.
Did he do the experiments alone?
He did the experiments together with many students, but all the key ideas came from him. He designed the experiments, prepared the necessary equipment, and checked every step himself.
How do you think he felt while doing the experiments?
He was very quiet on the outside, but deep inside, he must have had great expectations. He believed these experiments could give important results, but at the same time, he probably also worried that the experiments might fail.
Were the experiments difficult?
Very difficult. The inside of the glass tube had to be almost a perfect vacuum. The electric field and magnetic field had to be controlled very precisely. Even one small mistake could ruin the whole experiment. So he repeated the experiments many times.
He never gave up?
Never. Even when the experiments did not go well, he tried again. His desire to know the secrets of nature was very strong, so he kept going.
Did he finally find out what cathode rays really were?
Not yet, but he started to find very important clues. He began to observe how cathode rays responded to different forces, and those observations led to the next experiment.
Is the next experiment more important?
Yes. In the next experiment, he finally confirms whether cathode rays are really light or whether they are tiny particles. That experiment was one that changed the history of science.
Can I hear that story next time?
Of course. In the next chapter, I will tell you about that experiment in detail. In the last story, we talked about the scientist who prepared his experiments. Now he started a very important experiment. He wanted to know how cathode rays responded to different forces. So he used electric fields and magnetic fields.
Electric fields and magnetic fields are those like magnets?
That is right. A magnetic field is a force similar to a magnet. An electric field is a force created by electricity. He placed these two forces near the cathode rays and watched how the cathode rays moved.
If the cathode rays move, does that mean they are particles?
There was a possibility. If they were light, they would not respond to these forces. Light just travels straight forward. But if they were tiny particles, they could be pushed or pulled by forces. So he wanted to check whether cathode rays would bend.
How did he do the experiment?
He created cathode rays inside a glass tube and then created electric and magnetic fields in front of them. He watched the path of the cathode rays very carefully. When the rays touched the inner wall of the glass tube, a small dot appeared. If that dot moved, it meant the cathode rays had bent.
Did the dot move?
At first, it barely moved at all, so he made his equipment more precise. He changed the strength of the electric field and changed the direction of the magnetic field. He spent a very long time repeating the experiments.
So did it finally move?
At one moment, he saw a very small change. The dot moved slightly to the side from its original position. The change was very small, but he did not miss it. He thought the cathode rays were responding to the forces.
Then cathode rays were not light?
He could not say for certain yet, but he had found an important clue. If they were light, they should not have moved. But the cathode rays did move. So he thought there was a strong possibility that cathode rays were tiny particles.
Did he try to confirm this further?
Of course. He used the electric field and magnetic field at the same time. The two forces pushed the cathode rays in different directions, so he could see more precisely how the cathode rays bent. He recorded the movement of the cathode rays and analyzed that movement using mathematics.
Can you find out things using mathematics too?
He was very good at mathematics. He looked at how much the cathode rays bent and calculated how strong the forces were. Through those calculations, he tried to find out the properties of the cathode rays.
What properties did he find?
He discovered that cathode rays carried electricity. The cathode rays had negative electric charge. That is why they responded to the electric field. Light does not carry electric charge, so it does not respond. This was a very important discovery.
So cathode rays were tiny, something that carried electricity?
That is right. He was now almost certain. Cathode rays were not light, they were very tiny particles. But he wanted to know more. He wanted to know how small these particles were and how light they were.
So he did more experiments?
Yes. He tried to calculate the mass of the cathode rays. This calculation was very difficult, but he did not give up. He recorded how much the cathode rays bent and how fast they moved. And based on those records, he calculated the mass of the particles.
Did the calculation succeed?
It succeeded, and the result surprised everyone. The particles were incredibly light, much lighter than an atom. This fact brought a huge change to science.
That story comes next, right?
That is right. In the next chapter, I will tell you how small the particles he discovered really were, and what kind of shock that discovery gave to the world. In the last story, we learned that cathode rays respond to forces. Now he wanted to know how small those particles really were, so he started calculating. He recorded both the speed of the cathode rays and how much they bent.
Can you find out the size from that?
It was difficult to see the size directly. They were too small to see with eyes, but he could calculate the mass. If he knew how small the mass was, he could understand how special those particles were.
How did he calculate the mass?
He looked at how much the cathode rays bent inside the electric field and magnetic field. Then he analyzed that movement using mathematics. He calculated how much force was acting and how fast the particles were moving. The calculation was very complex, but he finished it to the very end.
What was the result of the calculation?
He got a surprising result. The particles were incredibly light. He found that the particles were about 1,800 times lighter than a hydrogen atom. The hydrogen atom was the lightest atom, so this meant there was something much lighter than even that.
So there is something smaller than an atom?
That is right. Until that time, people believed that atoms were the smallest things that could not be divided any further. But his experiment broke that belief. It was revealed that inside an atom, there were even smaller things.
People must have been very surprised.
Very surprised. Many scientists did not believe it at first. The idea that something smaller than an atom existed was too new. But his experiments were very precise, and anyone could repeat them. So more and more people gradually accepted his results.
That small particle is the electron, right?
That is right. He called that particle the electron. The electron was a very tiny particle with negative electric charge. Electrons existed inside atoms, and they played a very important role in explaining the structure of atoms.
Science must have changed a lot after the electron was discovered.
It changed enormously. The discovery of the electron completely changed the way people thought about atoms. An atom was not something that looked like a solid ball. It was a complex structure with tiny particles inside. This idea was a great revolution in science.
Did he know how important this discovery was?
He probably knew to some extent, but it was probably very hard to imagine how big an impact this discovery would have in the future. The discovery of the electron influenced every field: electricity, chemistry, physics, and even modern technology.
So this discovery was truly a huge change.
That is right. This discovery was a small revolution. A very tiny particle changed the world. People now knew that atoms were not simple things, and this discovery became the beginning of new research.
Next comes the story of the atomic model he created, right?
That is right. After discovering the electron, he tried to explain what an atom looked like. So he created a new model. I will tell you that story in the next chapter. In the last story, we talked about the discovery of the electron. Now he had to explain how electrons were positioned inside an atom. So he created a new atomic model. That model is called the plum pudding model.
What does the plum pudding model look like?
He imagined the atom as one round pudding. The whole pudding had positive electric charge, and inside it, small electrons were embedded like raisins. That is why it was called the plum pudding model.
Why did he create that kind of model?
He already knew that electrons had negative electric charge, but the atom as a whole did not carry any electric charge. So he thought that positive electricity was spread widely inside the atom, and negative electrons were sitting inside it. This way, the total electric charge would balance each other out.
Was the model easy for people to understand?
Very easy. You just had to think of an atom as one soft lump with tiny dots inside it. So many people accepted this model. At that time, nobody knew how electrons moved, so this model seemed quite reasonable.
So was this model perfect?
It was not perfect. But at that time, it was the best explanation available. It was the first model to explain that electrons exist inside an atom. So scientists started more research based on this model.
How do you think he felt after creating this model?
He was probably satisfied. Discovering the electron was already a great achievement. But on top of that, he also tried to explain the structure of the atom. He must have felt that he had opened a new path for understanding atoms.
What did other scientists think about this model?
Many scientists found this model very interesting. The idea that tiny particles existed inside an atom was a completely new thought. So this model stimulated the imagination of scientists everywhere. But some scientists thought the model was not complete. So they wanted to do more experiments.
Those experiments later led to the discovery of the atomic nucleus, right?
That is right. One of his students wanted to test this model by doing an experiment. That experiment produced a very surprising result. The result showed that there was a tiny nucleus inside the atom. But I will tell you that story in detail in the next chapter.
So the plum pudding model was later found to be wrong?
It was not completely wrong. The idea that electrons exist inside an atom was correct. But how the electrons were arranged, and what kind of structure existed inside the atom, those things were revealed more accurately later on. His model was an important first step.
Still, it had great meaning.
That is right. This model played a very important role in understanding atoms. Science always develops this way. First, a simple model appears. Then, based on that model, a more accurate model is created. His model was an important part of that process.
Next comes the story of the experiment his student did, right?
That is right. In the next chapter, I will tell you how his student discovered the atomic nucleus. That experiment created another great change in science. In the last story, we looked at the plum pudding model. Now I want to talk about how that model led to new discoveries. His findings had a big influence on many scientists, especially his students, who did deeper research based on his ideas.
Who were his students?
The most famous one was Rutherford. He was a very talented experimenter. He wanted to know more precisely what an atom looked like. So he did an experiment using gold foil. That experiment led to the discovery of the atomic nucleus.
What was the gold foil experiment?
He fired tiny particles at a very thin sheet of gold foil. Most of the particles passed straight through the gold foil, but a very small number bounced back. This result showed that there was a hard center inside the atom. That center is the atomic nucleus.
So the plum pudding model was wrong?
It was not completely wrong, but an important part was not correct. The idea that electrons exist inside the atom was right, but the idea that positive electricity was spread widely was wrong. The positive electricity was concentrated inside a tiny nucleus. This fact completely changed the understanding of atomic structure.
How do you think he felt when he saw that result?
He was probably surprised, but at the same time, he must have been happy. The fact that his student had discovered something new meant that the path he had created was right. He had helped his students make even greater discoveries.
Did he have other students too?
Yes. Among them was a scientist named Bohr. He tried to explain how electrons moved inside the atom. He thought that electrons moved along specific orbits. This idea developed the atomic model even further.
So his discovery influenced many people?
That is right. His discovery was not simply finding a tiny particle. He opened a new era of science. His experiments became the foundation that allowed other scientists to do deeper research. So his discovery continued like a chain of dominoes. One discovery created another discovery.
Did he know that?
He probably knew to some extent, but it was probably very hard to imagine that his discovery would change future science so greatly. He simply wanted to know the secrets of nature. But that small curiosity created a very big change.
Is his discovery still important today?
Extremely important. Understanding electrons and atomic structure is the foundation of modern science. Chemistry, physics, electrical engineering, and many technologies we use every day, all of them started from his discovery. Without his research, science today would be very different.
He was truly a very important person.
That is right. He discovered a tiny particle, but that discovery had an enormous impact. So he remains an important figure in the history of science. His research continues to inspire many people even today.
Next comes the story of how electrons created modern civilization, right?
That is right. In the next chapter, I will tell you how electrons changed our lives. When you find out how that tiny particle created the world we live in today, you will be truly amazed. This is the final story. After the electron was discovered, the world started to change very quickly. At first, it looked like a small science experiment, but as time passed, the electron became the center of many technologies. Today, we are going to talk about how that change happened.
Did the electron really play such an important role?
A very important role. Electrons are absolutely necessary for making electricity. Without electricity, you cannot turn on a light, and you cannot run a machine. Electricity is created by the movement of electrons. So the discovery of the electron opened the age of electricity.
Once electricity existed, people must have created many things.
That is right. At first, simple things like light bulbs were created. A light bulb is a device that produces light when electrons move through it. Once light bulbs existed, people could work even at night. Cities became brighter. The way people lived changed completely.
What else was there besides light bulbs?
Electrons also played a big role in communication technology. Devices like radios, telephones, and televisions all use the movement of electrons. Electrons send signals, and those signals are delivered to people far away. So people became able to talk easily with others in distant places.
Then the computers we use today are also thanks to electrons?
That is right. The computer is one of the most important inventions representing the age of electrons. Inside a computer, there are very tiny circuits. Inside those circuits, electrons move quickly and perform calculations. Without electrons, a computer cannot work.
Is a smartphone the same principle?
Smartphones are the same. Inside a smartphone, there are small semiconductors. A semiconductor is a special material that can control electrons very precisely. Depending on how electrons move, the screen turns on, photos are taken, and the internet connects. Many functions we use every day are all thanks to the movement of electrons.
I did not know electrons did so many things.
Most people cannot see electrons directly. They are too small to see with eyes. But electrons are at the center of every technology around us. Without electrons, modern civilization would be completely different from what it is today.
What kind of world would it be without electrons?
It would probably be a much slower and darker world than today. Without electricity, there are no machines, no computers, and no internet. Hospital equipment would not work, and transportation systems would not be as fast as they are now. Electrons made our lives faster, more convenient, and safer.
So the discovery of the electron was truly a huge change.
That is right. One very tiny particle changed the world. It started from a simple experiment, but that experiment became the foundation of modern civilization. It is a great example of how a small scientific discovery can create such a big change.
Did that scientist imagine this kind of future?
It was probably very hard to imagine. He simply wanted to know the secrets of nature. But his curiosity and effort opened the age of electricity, the age of communication, and the age of digital technology, all of them. His discovery continues to have an influence even today.
It is amazing that something so small can change the world.
Science often starts from something small. One small question creates a big answer, and that answer can change the world. The electron is a perfect example of that. That is why scientists always try to find new things, because a small discovery can create another new future.
Today's story was really interesting.
It is amazing that one tiny particle created such a big change. One day, you too might create a big change with one small question. Science is open to everyone. What matters is curiosity and the desire to keep learning. The journey of the electron that we talked about today also started from that kind of heart.